Hi everyone, great to be here, and thank you so much for such a not humbling presentation of myself. So the decentralized block building on Swarm, it's a result of lots of conversations around multiple topics at Flashbots. So first of all, building Swarm as a chain. Second, always planning to arrive at the decentralized block building. And the third, a lot of my work with the team in the last few months on the L2 PBS that led to thinking deeply about how to create interfaces between Swarm block building and different types of chains. And we'll review how Swarm can connect to different type of proposers, sequencers in various conditions. Because this is new and it's a bit of exploration with from conversations with researchers from the last few weeks, so maybe a bit of a note that this is a bit like working in the open. It may not be what Flashbots will in the end propose as a solution, but it's, I think, very, very likely next direction, next few months of delivery, engineering delivery of my team at Flashbots. Okay, so this slide you may have seen before because this was published by Flashbots as a description of what is Swarm. So Swarm brings a chain where developers can deploy smart contracts written in MEVM. MEVM is simply EVM expanded with a set of pre-compos that allow you to access some off-chain executors in the trusted execution environment within SGX or other model which can be trusted, like Flashbots initially, can be SGX, so there's a bit of trusted in Intel, and can be in the future some kind of software-based or cryptographic-based solution that allows for computation, arbitrary computation on private data. After the smart contracts are deployed on Swarm chain, when you have access to something that we call a confidential data store, confidential execution engine, the progression of Swarm chain doesn't have to be bound to the progression of other chains. So something that may come at the beginning as a very natural intuition is that Swarm will be a chain that maybe will build blocks every 12 seconds or even slower. So how can it participate in building blocks on faster chains that have 1 or 2 seconds progression? So this is unrelated because the building blocks on Swarm means that you're just deploying new contracts that participate in composability of block building and order flow access. But actually creating blocks for other chains happen through the RPC calls and access to those SGX nodes and the centralized cooperation of those invocations from various builders. So now we have developers deploying the models. So you can think of any of the leading MEV builders that deploy different types of solutions for solving MEV. So you can think of Polygon Fastlane, and I think coming from SNG and Consensus, you can think of various order flow providers. They will be the target of this, like as developers, will be target of SDKs that we build in the chain as a platform for them to deploy the mechanisms. The users will be very often like indirect delivery of order flows. So the user intents transactions, whatever, either filtered through the UIs. You can think of Uniswap of 1 inch and so on and so on. Or it can be directly flowing through the mempool or somehow being delivered by Flashbots Protect to this blockchain and the confidential data store. So one thing that we care a lot about is to solve the problem of having access to the order flow with protection for users and having decentralized access so anyone can access this order flow at the equal conditions. And executors would be the ones that are making calls to Swarm chain through RPC, most likely, or some other remote call method, to start building, participating in decentralized block building and the order flow access and delivering those blocks to the proposers on chain. And Swarm itself, execution nodes that can run state access and Ethereum virtual machine with the nodes, Ethereum nodes, but maybe also L2 nodes or other chains. Confidential data store for storage of order flow, but also unfinished or unpublished blocks. And MEV chain that is correct. And then today we'll focus on that thing on the right, which was very unclear maybe in the past, but now I'm trying to clarify it a bit. So maybe one other visualization of that. So you see Swarm chain having smart contracts. The smart contracts, just was imagining some examples. Who can deploy it? So you have an access gateway for Redis encrypted transaction pool, or the Polygon Pascaline style solution of smart contracts deployed on Swap, or Uniswap Flow Access Gateway, Chaos Swap Access, 1-inch blur, and then different builders deploying their smart contracts. Just giving examples of some of those that have the highest market share. And one thing that is, again, intuitive is like the question, are these builders even willing to deploy any of their secrets on chain? Most likely, they won't be deploying their secrets on chain. They will just deploy some components to have alternative ways of using Swap in case the order flow on Swap is valued much more than their exclusive order flow or private order flow that they receive in centralized builders. So it will be always a bit of competition between the Swap chain using the order flow that is protected and publicly available building blocks for block building, and the centralized builders that we know from the nowadays market of the PBS and relay builders. And now, once again, maybe visualization of the process. So having the Swap chain, you're making calls to the smart contracts. You invoke them more like for the RPC calls, and you may call like the builder. The builder accesses some order flow, smart contract that may introduce some kind of payment for access, or some kind of like enforcement of commitment to payment. So because it's a fully expressive MEVM model, you can really deploy any type of payments for order flow. They can be defined on the order flow like meta transactions by themselves, or it can be gated by the smart contract saying, okay, if you want to access this order flow, I'm giving you the unlock access, some kind of token that you can use inside SGX, but only for now, and only if you deploy the payment that's related to the value of the order flow. So like kind of, you have an entry to the SGX inside. You can imagine that you enter the, let's say, blur, right? So you enter the blur gateway access and you promise the payment, you get access, and a bit like in a flash loan. If on the exit you make a payment related to what you built, then it's fine. Otherwise, you'll be reverted. And each time I call multiple different order flow access calls, and I construct the blocks. And it might be that two different builders participate in a single block construction, because unfinished block can be stored inside the confidential data store, inside the TE. And you may have multiple blocks that are actually competing for which one beats the most. So it's a bit like in the nowadays PBS design, you have different blocks making beats and the relay choosing which one is the most valuable. But I think that composability here is something that we didn't see before. So a builder saying, okay, I construct part of the block, but I didn't close it. And maybe other builders will find something, and we could participate by having access to different order flows, maybe the exclusive ones. And here you see the flow where the proposer, so you have kind of like two flows. One is where proposer is trusted, so the model like nowadays without the relay, or where you have a relay actually. So you have proposer and not trusted, and you have some kind of out of protocol trusted relay like in the PBS on Ethereum. So proposer makes a call to say get best block, the best block is returned, and proposer can publish it to the network. So see here is like entire trust in proposer, because proposer, when they receive the block from, it can be whitelisted, almost like you'll be whitelisted, so only that proposer can access from inside the SGX the block that is built. And the relay would probably follow something like nowadays where it gets the header and then has to deliver the header that is signed. And then inside SGX, we're verifying the same way as nowadays relay verifies if the signature is correct and represents the current proposer on the network. If it is, then the payload is released and the relay can forward the block. So practically here, Swap acts like this auctioning part, a building and auctioning part of the PBS. This can also work with shared sequencers. So Swap itself is not a shared sequencer. It can use shared sequencers for delivering more valuable block construction models. So as a shared sequencer, it can say, get the best block that actually uses the opportunity to atomically propose on Optimism and Ethereum at the same time. So I say they provide the parameters of what type of blocks I can accept. And as a response, I may, you see like here, the proposal is, sorry for small letters, Ethereum 0.4 ETH block, there's Optimism 0.2 ETH, but maybe some builder can build a block that contains both, and it has this like cross-chain components, like the top of the block atomicity transfers between the two different chains, and they bring additional value, making it 0.7 ETH. And since it's a shared sequencer, so only that sequencer will be allowed to access the blocks that are cross-chain building. And here you see the model where exactly Swap is in some of the maybe known boards that I was showing before. So Swap becomes like one of the builders participating in the auction with the relay, right? So when relay asks Swap for the best block, it's the same way as the relay asking builders for the best blocks. So Swap still has to compete. So Swap itself may have a competition internally between the block builders, whether it's like collaborating block builders or the ones that just use the different order flow access. It has to be better than the centralized builders. And this is the model where you have trusted proposers, so there's no relay, but the proposer runs the auction themselves. And again, it may be building locally or maybe comparing the results of the centralized builders and so on. Now, a few models that are known from L2s nowadays. So this is a model from chains like Tyco, which are base rollups. So in the base rollup, you have proposers sending transactions to the L1. And those transactions represents blocks on Ethereum, on layer 2. So proposer sends a transaction being a Tyco block. And different proposers are competing with themselves on which one will be accepted as first in the smart contract. So they kind of have to pay to the L1 builder for the priority. So all the MEV is captured by L1. But there's a recent proposal from Connor McMenamin, and we're about to publish a bit more in detailed description, where we're actually alternating the base rollup with the PBS auction. So at any point, you can decide whether you publish a block as a proposer for the backdoor function, where you have a specific constant payment, or maybe payment that follows some kind of rule like EIP 1539 when it goes up or down, depending on how many proposers try to compete for that backdoor. Or you can go for a trusted set of whitelisted proposers from the protocol that are capturing MEV. So here you have MEV capture and more promises to the builders. Swap can participate in this auction. And here we have permissionless proposers for the base draw, where MEV is actually captured by L1. This is a proposal of introducing PBS to FCFS systems like Arbitrum. Again, this very likely will never be introduced by Arbitrum, but maybe we start to work on this one. So you say that actually there can be a benefit of switching between fast blocks and slow blocks. So every X batches that Arbitrum proposes, you may create an auction for a batch that does all the like reconciliations and auction and actually allows some participants that would never send the transaction to go for the FCFS, like for whatever reason, like they think that the losses from the reverse would be too high. Every time this block is being offered, you it's a bit like you're competing for top of the block opportunity, and again, you can have Swap competing with other builders for the proposer PBS within the FCFS model. Because this is the standard Arbitrum of like create a batch, do the first come first serve, and then reorder them by the gas price rate. This is something that I think we will all witness over the next 2 to 3 years. So the model where you have a mix of all the potential solutions coexisting. And it was very important for me when thinking about Swap block building that we cannot propose a single solution for block building and assume that every single L2 or L1 will go that direction. Because after a few months of conversations with L2s, what we see is that the models are extremely different, right? So you have Arbitrum FCFS, you have Tyco base rollup, you have Optimism that goes with proof of governance and very much PBS, relay PBS style like we used to see, and a few others. And they go also at different pace, like they have engineering teams prioritizing different aspects of decentralization. which means that we'll see some kind of centralized sequencers, shared sequencers, maybe cross-domain swap building like we've seen with the shared sequencer opportunity for Ethereum optimism. Builders participating with the relay model like nowadays. Some base rollup, base atomic sequencing, so using layer 1 as a shared sequencer. There'll be panel today at Pragma about it. And once again, how do we ensure that the blocks built on Swav win? So they have this confidential order flow value. So some order flow may only be available for decentralized builders, for those who access it via Swav. So that order flow will not go to decentralized block builders. The transparency of mechanisms. So by building together all those mechanisms and composing them, the community may arrive at much more efficient models than the competition. Maybe not entirely because it's transparent, so you can always copy those models, but the composability may actually connect the greatest strengths of different builders, right? And this is it, builder composability. What centralized builders will have is like probably much better simulation rates, proprietary algorithms for the block building that are not deployed on Swav. Exclusive order flow values, so any order flow arrangements where the order flow either is private, generated by the market maker that is also a block builder or searcher block builder, or the one where there is a off-chain arrangement agreement to redirect order flow only to one builder. And I think that maybe this will be less of a problem than we imagine nowadays, but likely decentralized builders will have lower latency in delivery via relays. When I think of solutions like the Titan relay now, that promises builders the lowest latency delivery, well, it can still access Swav, right? We were showing that the relay can access Swav. And the block building, that composability for sure will be coming with higher latency, but will not necessarily have to compose different builders' work. So hard to say yet what exactly will be the latency difference. That's it from me. Not sure if you have time for questions or need for questions, but thank you so much.
Hi.